Hey, this is Mrs. Davis. This is AP Pre-Calculus, Lesson 1-5, Polynomial Functions and Complex Zeros. All right, and we're almost to the end, so just bear with me. The very last thing that I'm going to do is going to be like the most important, so I hope that you were able to stick with this and take notes for the whole lesson. All right, so here we go. Let's talk about inequalities. Okay, so polynomial inequalities. You have to realize that it's not like a linear inequality. You have to do a sign chart. So here's some information. If a is a real root of a polynomial function, then the graph y of px has an x-intercept at the point a0. So real zeros can be endpoints for intervals solving polynomial inequalities. So you solve the inequalities using both algebraic and graphic techniques, and so we're going to do the ones that aren't graphing, because you know how to graph and look for things that are less than or equal to. So to solve for x greater than 0, we find all the values of the x that makes the function positive, and for y for less than 0 that make it negative, which is totally very obvious, okay, and probably unnecessary to put. So how we're going to do this is use a end behavior to determine what's happening to the polynomial around its zeros. So we take the first function, this function, and we look that it has x plus 3 and then x minus 4 squared are its factors. So if I wanted it 0, each one of those would be set to 0. So I have the zeros x equals negative 3 from that term. And then I have 4 multiplicity 2. I have multiplicity 2 because this is raised to the second power, meaning it's x minus 4 times x minus 4. So there's your multiplicity, and that's going to come into play in a minute. All right, so where is this positive? So what you do is you take your zeros, so pay attention, this is very important, and you're going to make a sign chart of your zeros. So I have a 0 at negative 3 and a 0 at 4. Okay, now it doesn't matter that this, your difference, are you making a perfect number line? Because all you care about is what's happening when you do the end behavior. So I have a third degree polynomial with a positive front coefficient. So that means my graph has to go like this. No other way to draw it. So that means I have to remember I have multiplicity 2 at 4, so I just come down and touch, and it doesn't come down straight, so I should have come in at a little bit of an angle. It comes down and touches at negative 4 and comes back up, and then it has to come back down through the 0 at negative 3. So those are my two zeros, but I knew that because of the multiplicity 2, I just came down and touched. So we have where that helps us decide where the function is positive and negative. So if you look, the function is negative before negative 3, and then it's positive, and then it's positive again. So now I asked us where it's positive, not where it equals 0. So make sure you understand that. So we're going to have to stop at 4 and not include 3 either, because 3 equals it. The function equals 0 at 3, and the function equals 0 at 4. It's not greater than 0, which would be positive. So I have to use soft braces or soft brackets. I go from negative 3, so here I'll use red here, negative 3, and then I can't include 4. I can't include positive 4 because it equals 0, so I'm going to go from negative 3 to 4, and then I have to go from 4 to infinity. So that's the positive, where the function's positive. And where the function is negative is, I am going to, let me use blue for that. It's just this piece. And it also is not negative at negative 3. So we would say negative infinity to negative 3. All right, so that was all because we could sketch this graph from the zeros using multiplicity to tell us whether we go through the graph or not. Very, 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 very important to be able to do that. So let's look at example 14. It says solve the polynomial inequality. So you have, it's less than or equal to 4x squared minus 16. You have to have 0 on the right-hand side in order to factor it accurately. So let's rewrite this as x cubed minus 4x minus 4x squared plus 16 is less than or equal to 0. So let's put it in the right form. X cubed minus 4x squared minus 4x plus 16 is less than or equal to 0. Now, I have to factor this. They didn't give me the zeros this time, or they didn't give me the factors. I have to actually do it, okay? And so it looks like this should be able to be done using, using grouping. So I'm going to look at it from here. I'm going to factor out an x squared, and I get a x minus 4. And then if I take out a negative 4 on the second half, I get x minus 4. And we still have less than or equal to 0. So you have x squared minus 4 and x minus 4 is less than or equal to 0. And now remember, this is a difference of squares, so we have x plus 2, x minus 2, and x minus 4 is less than or equal to 0. Now, they like to call, some books call these zeros critical values or critical points. So we can say that's x equals negative 2, x equals 2, and x equals 4. Now, we are going to take those critical values and again make a sign chart or a chart that puts the zeros on. So I have a negative 2, 2, and 4. Those are my zeros. Okay. And now I have third degree. So my shape is the same as the last one, only there's no multiplicity. So I have to come down through this. Remember, it's going to be in this shape like this, right? So I'm going to come down through that. Only way I can is to come back up through the 2 and go back down through the negative 2. So again, we don't really care about the mins and max to do what we're doing now. And so now let's go back and look what it asks for, it less than or equal 0. So that this time we can use the negative 2, and then it's from 2 to 4 here. So our answer would be, where it's less than is negative infinity to negative 2, hard bracket, because 2 is included, it is equal to 0. Union, hard bracket, 2 to 4, both hard brackets, because those zeros are both going to be included. So when it says solve it, it means find the x values where it's less than or equal to 0. And so this would be the answer. All right. And this very last thing kind of puts all that together. They have factored the first couple for you, so we should be able to zip right through this. So for each of the following polynomials, determine the degree, find all real zeros, state the multiplicity, and sketch. Sketching comes from finding all those things. So the first thing we're going to do is look at f of x's dysfunction, and we have a degree of 3 plus 1 plus 2, so that's degree 6. All right, we have real zeros of 0. Well, let's do them in order. I have a negative 1 here, no multiplicity. I have a 0, and it's x cubed, so that has multiplicity. Let me take the comma out so you can see. Multiplicity 3, and then 4, multiplicity 2. So I'm going to write that so it fits on my page. So one more time, I have x equals -1, 0, multiplicity 3, and 4, multiplicity 2. So those are my zeros. All right, and so I have degree 6, so my function's going to have to point up both one. Oh, no, we have a negative 2x cubed right here, right? So because we have a negative coefficient, we would point down. Okay, so let's put our zeros in. So we have one at -1, one at 0, and one at 4. All right, and so we're actually, I should erase this so you don't have that in your notes wrong. We have to come through -1, okay, and have no other option. Now, we have 0 multiplicity 3, so that's not an even multiplicity, so it goes through still. So it comes through 0. And now 4 has a multiplicity 2, so when it comes back around, it doesn't go through it, it just goes back down again. So there we have a sketch of that function. And that's, you know, after we can do this, we can say all kinds of things about it, including any inequalities or anything. So let's look at the next one. Our degree is 4 plus 2, so this one is also degree 6. This time we're going to have a positive front coefficient. So this time our graph will look up both of them. And let's pull off our zeros first. So we have, oh, they didn't finish factoring the x squared minus 4, did they? So let's do that as x plus 2, x minus 2. And then we have x minus 2 to the 4th. So wow, so that means, shoot, let's rewrite this better. That would be 3x plus 2, and then x minus 2 to the 5th power. All right, so that changes things. It's still 6th degree. I still am going to point up. But when I list out my zeros, my multiplicity have changed. I have -2, which is just multiplicity 1. And then I have 2, which is multiplicity 5. So that is a odd multiplicity, so it doesn't just touch, it goes through. All right, so we're going to sketch it. Okay. And I don't know why I put that there. I want to do it the other way. We have -2 and 2. Okay. And so it's degree 6, so it probably has some turns below these zeros, but for what we care about, we just need to know that, you know, it could do something like that. It comes up through -2 and 2. All right, so that's how that one would look. Again, these are sketches. All right, let's look at this last one, last thing for this lesson. We have degree 3 and degree 2, so together that would be degree 5. So we're going to say degree 5. All right, now we have to factor each one of these. So the first set, this first trinomial, will factor out an x because each term has an x in it. X squared minus x minus 6. All right, and then this we can go to x minus 3, x minus 4. So we can do this one more time. X, and that would be 3 and 2 with a -3. X minus 3, x plus 2, and then x minus 4. So let's combine, oh, and x minus 3. So we have these two to combine for a multiplicity. So we have x minus 3 squared, x plus 2, and x minus 4. So 1, 2, 3, 4, 5. We have degree 5. So our zeros are -2, and then 3 multiplicity 2, and 4. Okay, those are our zeros. And I think I forgot one. We have 0 here on, don't do that. We have a 0 on the outside, because if you counted, I'm supposed to have 5, and I had 1, 2, 3, 4. So there's a 0 in here. All right, so now we're going to sketch this again. Just need this side. And we have a -2, we have 0, we have 3, and we have 4. All right, we have 5th degree, positive leading coefficient, so it has to go in that direction. It has to go through those, 1 up and 1 down. All right, so 4, it goes through because multiplicity is 1. So I'm going to come down here and come through 4. Now 3 has multiplicity 2, so I'm just going to come up and touch 3 and come back down. 0 is just multiplicity 1, so I have to come back through that. And -2 is multiplicity 1, so I have to come back through that. So there's your graph shape. Okay, again, it's just a sketch. All right, so that ends 1-5. Quite a bit of material in this. Hopefully a lot of it is review, just putting some things together and reminding you of things.